Hi everyone, welcome back to this workshop with this new video. Today I'm gonna show you how to use loops into Scilab. So get ready for that and let's jump right into it just after the intro. See you guys. Okay, here we are. I assume we all already know what this is, and if you don't, just check out the last video I've uploaded talking about condition, how to use if and switch into Scilab. And at the beginning of that tutorial, I talked a little bit about Scilab and what this is. Okay, so right now let's just jump straight to the main point of this new tutorial. Today we're going to talk about loops, and most of the time we need loops because it's that type of instruction we use when we want our program or our algorithm to make something at least 2 times. For example, if I want a code to say hello at least 2 times, I will need, or it will be nice because maybe someone will say let's just type this 2 times in your code. But let me tell you something, if you want something like this, so let's type let's type this before and say okay. So you probably remember about this. Okay, we talked about it in the last video, so let's make another one. Oh, I should use this, but no, it's okay. Let's make a new one. So let's say, for example, I want to say hello 5 times into I want that message to be printed in my screen at 5 times. So let's say I would type this hello, and okay, this is loops test on Scilab, and let's say copy and paste. Okay, I can paste it like that. So let's just, you see, the problem is if I want this message to appear something like, I know this is not real, but let's say, for example, I want this message to appear 100 times into my screen. You realize I will have to type this line 100 times. This is huge, pretty much huge. This is so it's not good at all, because let's say if I run this, you see it is doing the job, but the problem is the code. The code is really hurting. We don't want this. But let's say instead of using this kind of let me say ugly codes, I may just have to type something like this. Okay, going from 1 to 100. This hello, and you'll see this, for example, was about 1, 2, 3, and 4, 5, 6. I mean, if I want hello to be printed 100 times, I'll have using this type of coding, I will have to write 100 lines to have my job well done. But with this, I used 1, 2, 3 lines. Sorry. So if I compile and run this, where is the prompt? Here is the same job, but with something, the same job, but with something more beautiful to look at. So this one is better and much easier to understand than this one. Okay, so don't use this type of coding. So when I want to use when I want my codes to do a specific task at least 2 times, this is the type of code I need inside my algorithm. So there is I think 2 type of loops. There is this one, the for loops for these things and instruction, and don't forget to close the door with end. And also I can have the same job with while. So let's say, for example, but there is difference. If you want to use while, you need to initiate your variable before you use it into the structure. So let's say while, no, before using, I say k is initially set to 0. So while k is less than 100, print the message, this hello. Oh, if you remember about this last, so this one, you really need to use codes when you're using this, because if I type just hello, it will think hello is a variable, but I want the message, not the value inside a variable. So let's compile and run this again. Maybe I should, no, let's see, hello with y. Compile, run, and let's check the output. See, there's a problem, okay? And I really wanted to show you that because there is something really interesting with while. You know, this is not gonna end, and this is because I didn't specify that I want this to end here. Now, how to do that? This value doesn't change, okay? Anytime the program is trying to run the structure, but there's something not going right here because k is always 0, so this condition will be always verified, so we will never reach at this point, never. So if I want this to end, I need to update after every single iteration. I need to update the value of k. So before the computer so no before it's not a computer, but the compiler, yes, before it check this condition, I need this value to be updated. So let's say k is equal to k plus 1. So something really fun is that if you want to trick your friend, you may type this kind of codes and say, hey, I have something cool for you, and let it run it into his computer. But you know, after several times, these things will spoil your laptop. So let's end this with, if you want to abort this kind of run execution, just type just press, sorry, okay, press, don't type it right here, just you press this K and this one, so Control plus C, and it will abort the run execution. So let's get back to our codes, and now let's run it. And if you run it, see, now there's not I mean, it's running perfectly right now. So that is an important point when you use this one, when you use Y. It's important. Another fact is, I may want, you know, this kind of structure is using iteration. What is iteration? Is simply a step of execution, if you allow me to say it like that, because when we talk about iteration, we talk about the fact that this structure, for example, will be executing this instruction 100 times. Now it is 100 times because I didn't mention any specification here about how to jump from one iteration to another one. For example, if I want this to be printed not 100 times but 50 times, I may need to type this. Now I presume, or maybe I bet, lots of you are now saying why to, but let me say, if you want to run from 1 to 100 with a step of 2, you will have 50. Yeah, 50. So it's simple to check. So let's say no, if I say iteration K, it will print so let's see. Anyway, you may check it on your own, because we are limited in time. So this will print, let's say for example I type 10 here, yes, and compile and run. So also here plus 10, compile and run, and it will count the number of messages I put in the screen. So you see 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So same here, 1, 2, 3, 4, 5, 6, 7, 9, and 10. Sorry, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So just because you specify that you want this to stop when K will be equal to 100 doesn't mean it will print this message 100 times. So if you specify the step, or how can I call this one, just say the step, if you specify the value of the step, it will take it into account and use it to print this message according to this value. Okay, so this is really important. And if you want to do the same with this type of structure, you will just type it like this. Okay, pretty much important. I don't know if in Scilab we use do while. So let me take this view right here and let's see if, but I'm not sure. So see, help do, you see? So no, these are the only structure for iteration into Scilab. So pretty much important. So when we will be digging deep into this workshop, because let me tell you that we are so far enough to the real point of this workshop. But it's important for me to make this tutorial for you because I really want you to feel confident with the basic concept of Scilab programming before we get straight to the first goal of this workshop. The first goal will be to achieve forward modeling, numerical forward modeling, to assess heat diffusion. Okay, so I hope this will help you to take a hand with this environment, and I hope also we'll be together again in the next tutorial. Until then, I'll see you, have a good time, and I'm signing out.